Hello and welcome to this repair tutorial, and today we're going to look at a NAD and the model number is C352. In terms of general specifications, power output is 80 watts per channel into 8 ohm speakers. Frequency response is 20 Hz to 20 kHz. Total harmonic distortion is 0.02%. For your input sensitivity for all of your line inputs, it's 770 millivolts. It accepts CD, video, tuner disc, aux, Type 1 and Type 2. You can bypass the tone control circuits from the front panel via the tone defeat switch. It also has a headphone jack socket for personal listening, and you have two sets of preamplifier outputs. On the rear of the amplifier you have a set of links, so if you wish you could connect one of the preamplifier outputs then to another power amplifier. At the rear of the amplifier it has a switch which is for soft clipping, and then in terms of dimensions, height, width and depth, you're looking at 100 millimeters by 435 by 290, and the amplifier weighs 7 kilograms. This amplifier also supports a remote control, so you can select any of the inputs as well as placing the amplifier into standby mode and operating the motorized volume control. So what was the history of this amplifier? Well, the owner contacted me, and from what I can understand, the gentleman had owned it from new, but he'd seen one of the repair tutorials, again for the same model, and had made a note with reference to one of the major common failures with the NAD amplifiers of this era, and these are these J H capacitors. So you can see this photograph here, and you can see that all of these electrolytic capacitors are indeed the brand J H, and I've covered this on multiple occasions on the repair tutorials. Basically what happens is over time you find that the value of the capacitors reduces, and then the internal resistance of the capacitor then increases. And you can get situations where the amplifier will remain in a standby mode. And the only thing that you can do is just really to do a block change of all of the electrolytic capacitors to get it to a known good reference point. In most cases it will resolve the issue, and then there's no reason to have any additional fault finding. But this amplifier was working, but it was a case, due to age, that the owner felt it was probably time now to replace the capacitors. The other issue, if we look at this photograph here, is this very common thing, which is this brown glue. Sometimes this can be a little bit misleading because it can look as if the capacitors have leaked, but that's not what has happened. They've simply, at the factory, put some glue around there to provide additional mechanical strength. And then over time what happens is this glue dries out, it becomes rock solid, but it has two other issues. It becomes conductive and it also becomes corrosive. So if there are electronic components like resistors or transistors, or even some of these wired links, you'll find that it will cause damage to them all. So as part of this recapping of this amplifier, all of this brown glue was removed and then the circuit board cleaned up. When you look here at the power input board, you can see these brand label capacitors NAD. And what you found with these capacitors, and again I've mentioned this on previous repair tutorials, when you desolder them from the board and you give them a shake, you'll find that they rattle, so they're completely dried out. If you drop them on the ESR meter, again same thing, you'll find that the capacitance value has dropped significantly. Sometimes you don't always see an increase in internal resistance, but what you do find is if you remove the capacitors and you discharge them prior to removal, you'll normally find that there's no charge in there at all, even if the amplifier has been powered up, so its ability to store energy has been dramatically reduced. That's an issue because this is really the reservoir. These capacitors of course charge up, and then when the amplifier is running, it makes sure that the required energy is available then to respond to a peak in music demand or increased drive if you're increasing the volume control. So on this photograph what we show you is the rear panel removed, and this is quite an interesting shot. You can see on the left hand side you have the bank of RCA input sockets. Then you have the single set of speaker terminals, and then the right hand side, this is the startup board, and you can see that there's a small EI transformer, there's a power relay, and there is some regulation on there as well, and there's a number of smaller electrolytic capacitors. Now with this amplifier, what you have at the bottom is a service plate, and this is pretty good for this amplifier because when you remove it you've got full access to the entire circuit board, so it makes the recapping process easier, and also as well we don't have to remove the main circuit board to get to all of those electrical connections. Now when we look at this photograph here, what you are seeing is a square or a red square which I've put around an area that you need to look at. This is the low voltage power supply section, so it's providing the lower DC voltage power supplies to all the different stages of the amplifier. And what you commonly find is, because it is generating heat, the solder joints in this section will have gone dry. So you need to, in many cases, just desolder the old solder to remove it and then reflow them with new solder. It's also important to go and check all of the other solder connections as well, just to make sure that there's no cracking around them and that there's no issue. As part of this particular recap, what I also did as well was not only to reflow the main board, but also to reflow the circuit board here, which is the power input board, and often you will find dry solder joints. The same applies also for the headphone jack socket, and then also your tone controls and your input selection board where you have the microprocessor. And then here what you can see are the brand new large 63 volt 22,000 microfarad capacitors have been installed, and then also the smaller capacitors. Now the capacitors that were chosen by the owner are Nippon Chemi-Con. So here this ensures that moving forward this amplifier really will be delivering many years of high quality sound. On this photograph, what we're showing you here is the speaker protection relay. Now because of the age of the amplifier, it is a common issue that the switching contacts internally become oxidized and resistive, and this can lead to low levels of distortion or intermittent sound loss. You can see what we've installed is a high quality Chirac relay. So this is a 24 volt relay and it's a double pole changeover, and again it's very important. So this has like gold switching contacts, which just means that it's delivering the minimum resistance, and I don't look to clean the original relay, it's just better than to remove it. And then to the right hand side you can see that there is a small slide switch, and this is to select the soft clipping. So during the recapping, that switch was removed, taken apart, the contacts internally cleaned them with a fiberglass pencil, and also De-Oxit applied to provide some longevity. And then these are the signal processing boards, not to be overlooked. And here I've just turned the amplifier onto its edge side, and all I'm looking for is dry solder joints on the multi-pin connector. And then you'll sometimes find dry solder joints on some of the transistors, so don't miss them out and just make sure that you resolder any of the bad connections there. The other thing is, and you can sort of see on the left hand side, these are one of the control potentiometers. Most importantly, you need to clean all of those, including the volume control potentiometer with De-Oxit D5. Just spray into the access hole and then rotate multiple times, and that will remove any oxidization or dirt which has accumulated over time. Now on the front circuit board where the microprocessor is housed, and we'll get to a photograph, you can just sort of see it on the right hand side, but I'll do a zoomed in view in a moment. This is the front fascia, and what you have is these clear transparent plastic light tubes. This is where the LEDs from the shrouded components that you see there shine through, and they're held in place with a double-sided sticky tape, but of course over time it has dried out, so when you remove the front bezel what you find is they just fall away. So what I've done is I've removed completely the old double-sided tape and then put in brand new strips of tape and then reinserted these. There's also some hot weld as well where you have the volume control. It's like a plastic shroud. So again, that was replaced. And then here when we have a look at the input selection board, you have the microcontroller. So you can just make it on the left-hand side, the crystal. And then there is one small electrolytic capacitor that you need to replace. So this is a 10 microfarad, 50 volt. When the circuit board is removed, also check on the rear for dry solder connections. You'll find that there will be some of them on the switching transistors, and then also some of the input selection switches. And then here what we're looking at is a top view, and you can see the high-powered Sanken audio output transistors. You can see the white emitter resistors as well. And then on that circuit board there is you've got two sets of presets which are used to align the amplifier, and we'll get to that a little bit later on. And you also need to spray De-Oxit D5 into that selection switch there, which is a push button one. This is where you have the tone defeat switch. Make sure that you operate it multiple times to ensure that you've got repeatability and no intermittent issue or anything like that. And then here we're just showing you the complete side view of the amplifier. And this is after recapping, so you can see that all of the brown glue has been removed. And then here, what we show you is a side view again, so you can see the speaker protection relay, and you can also see the input board as well for the power supply. Really easy to work on, but you do need to remove the back panel. There's just 4 screws, and then just unclip it from the main amplifier board. And then in terms of alignment, here what I'm showing you is an extract from the service manual, and this being the left channel. And you've really got 2 adjustments that you make on each channel. The first one is the offset voltage adjustment. So when you look at the circuit board, what you see is that there are 2 operational amplifiers, one for each channel. And what you need to be looking at is the output pin, which is pin 1, in this instance IC107. So you're just going to connect your negative lead of your multimeter to your negative left channel speaker terminal. And then just be careful, you don't want the multimeter lead to slip. And then you're going to make the adjustment here until you're reading less than 100 millivolts. Now, both for the right and the left-hand channel, it had drifted out and it was significantly higher than 100 millivolts. But remember, with these preset potentiometers, they can become dirty over time, so you might want to just spray some De-Oxit into there and just rotate them backwards and forwards with the amplifier powered off, and then return them to a position they were previously. So here I'm just measuring, of course, this 100 millivolts, but the output will be plus or minus. Okay, so if it goes negative, then just increase it or decrease it until you've got it to where you need it to be. And then the other part is that you have 2 sets of test pins which protrude from the circuit board. And what you have to do is connect your multimeter across, set to DC millivolts, and then you are measuring from 5 to 6.5 millivolts. So you just make the adjustment within that range. Now, you wouldn't have any speakers connected or headphones. Your volume control would be at minimum, no input, and then your other user controls then at midpoint. And then allow the amplifier normally to stabilize after about 15 to 20 minutes. Repeat the same exercise for the right channel, and then probably leave it another 10 or 15 minutes, and then just recheck. In most cases, you won't need to do a new adjustment, but you might do a little bit of tweaking just to get it back to the factory standard values that you see here. So here I'm just showing you the bias which is being set on this amplifier. Now, you've got these copper rails. So what I would say to you is don't sort of try and get your hook-on clips with the amplifier powered up, because it's very easy to maybe slip. So what I do here is I just leave the amplifier powered up for 20 minutes, nice and warm, switch it off, make my connections with my hook clips, and then power the amplifier back on, let it stabilize for a few minutes, and then make the adjustment. So here, as we step through, you can see that we've then hooked up, as I said, and then we've then made the adjustment here. So we're reading 5.52 millivolts, so well within the range. And then also as well then for the other channel. So this one coming in at 5.41 millivolts. And then here, when we look from the top, you can see all of the work has been completed. Now, just a note with regard to recapping of any amplifier. The first thing that you want to do is make the time. All right, this isn't something that you will be rushing. And then when you are stepping through, what I do is I don't remove all of the capacitors. I take each capacitor one by one. So I know that when I remove it, I can check to see what the value of the capacitor is, and most importantly, what the operating voltage is. And then I'm making sure that when I insert the capacitor, that I've got the correct orientation. And then sometimes the solder connections are quite close together. So you also need to ensure that you don't get any solder bridges. And remember that some of these capacitors that you will change will be 47 microfarad, but there's also a 4.7 microfarad capacitors as well. So it's very easy to get these mixed up because maybe you don't notice the decimal point. So just double check your work as you're going through. Now, near to the volume control potentiometer, there is a smaller capacitor, and this is C349, and it is a 22 microfarad 50 volt capacitor. But please note that it is a NP type, which means for no polarity. So that means it can go in either way around, because the signal there could go positive or negative. And then finally, here what you can see is all of the fail components removed. So what I've done here is I've replaced all of the electrolytics, which you can see in this small tray, the large power supply ones. And then you can also see as well the speaker protection relay. And there is a small power resistor as well. So this resistor here is 680 ohms, and its wattage is 2 watts. Now what you find in this amplifier is it just goes stinky. So you can actually smell it. So what I do is I just replace that resistor there, and I've put a note in the description for the video and then the reference number for that resistor. So the only thing that remains then is just to leave the amplifier on test, and here it typically ran for about 3 to 4 hours and a number of different power cycles. But the amplifier worked perfectly, really delivering a high quality sound, and I'm confident then that when the owner receives the amplifier back, they're going to be receiving many years of listening pleasure. So that sort of brings us to the end of this recapping tutorial, shall we say. And if you need any guidance or assistance, by all means email audioamplifierservicing@aol.com, and I'll be more than happy to come back to you and provide any guidance that you may require. So until the next time, I wish you all the very best. Cheers and bye-bye.